Hey guys, it's Mr. Dorado here, bringing another lesson for section 4.2, which is a continuation of our unit on inequalities. So, just to kind of recap, inequalities are similar to equations in terms of how we solve them, but the solutions that we get from inequalities are actually very different. We actually get a solution set. We get a set of answers that actually represent all the possible solutions for an inequality. But now, like I mentioned earlier, they are very similar to equations in terms of how to solve them. So in order to understand how to solve them, let's go ahead and recap a few things on solving when we have variables on both sides. So what we're going to do is actually look at how we would do that in an equation and compare it to how we would do it now with an inequality and see where the differences and similarities are. Okay? But just since we are focusing on inequalities, let's go ahead and recall a few important things from inequalities. So I'm going to go ahead and put a little star here because I really want you guys to remember this one. Okay? So one of the biggest things with inequalities is that you have to flip, okay? You have to flip an inequality when multiplying or dividing by a negative number. Okay? I just wanted to make sure I pointed that out, and it is something that we talked about in the last section, but I want to make sure you guys are still understanding that we have to do that flip whenever we multiply or divide by a negative number. So let me go ahead and highlight a few things here. So we flip the inequality when we multiply or divide by a negative number. Okay, now by flipping the inequality, all I really mean is we're going to have to flip the sign. So if it was a less than, it turns into a greater than, and if it was a greater than, it turns into a less than. So because I mentioned those few key terms here, let's go ahead and actually go back into identifying what the symbols are and what terms describe them. So this symbol here means less than. Again, if it helps you remember, this symbol looks more like an L, okay? So because it's like an L, we know it's the less than symbol. This one right here is actually our greater than symbol, okay? So that is our greater than symbol. Now, if we look at these two, they're very similar. So it's also a less than, except for now it has that little line underneath, so it's less than or equal to, okay? And then finally, once again, those two are the same, so it's greater than or equal to. Okay, awesome. So let's go ahead and also talk about how we have to show this on the number line. So we have open circles when we have the symbols less than and for the symbol greater than, and then we have closed circles when we have the symbols less than or equal to and greater than or equal to. Okay, so like I said, we're going to have to solve inequalities in a similar fashion that we did equations, with just a few exceptions on the rules on that. Okay, but because they're very similar to equations, let's go ahead and practice an equation problem. So this is one with variables on both sides. Okay, the first thing you check right away, can I distribute? Okay, and you can't distribute anything here because there is no parentheses. Second thing you check is to see if you can combine anything on the left side of the equal sign or anything on the right hand side of the equal sign. In this case, none of those are like terms on the left, none of those are like terms on the right. So the next thing is to get the variables on one side. Well, we have two sets of variables. We have a 2a and we have an 8a, which means we have to move one of them. Now, our general rule of thumb is to move the smaller one. So I'm going to subtract 2a. What do I get? I get 13 equals 7 plus 6a, and this just becomes a SADMAP problem. Now we get rid of any addition and subtraction first. So subtract the 7, I get 6 equals 6a. If I divide both sides by 6 there, I'm going to get a equals 1. Okay, so this is all I did. If you guys aren't sure what I did there, I divided both sides by 6. 6 divided by 6 is just a 1. So a equals 1 is my solution. If you guys remember from the last lesson, all you have to do is put down your number there. And okay, well, it's equal to, so that number works as a solution. So we can go ahead and close it in because that's the number that works. But that's the only number that works, so we don't shade left or right on the number line. Number 1 is the only one that works for this particular equation. And again, if you want to make sure that makes sense, all I'm saying is that 1 is the only number you can substitute in here and here, and you would get answers that are exactly the same on both sides of the equal sign. But again, if you want to prove that to yourself, you're more than welcome to try it out. I'm not going to go ahead and take the time to do that right now because I know we've practiced with equations. So what I want to do is actually focus on inequalities. Okay, so similar situation. Can I distribute? No. Can I add like terms on both sides of an inequality? Well, the p and the 7 aren't like terms. The 10 and the 4p aren't like terms. So I can't do that. Now we just make sure we have the variable on one side of the equal sign. Or I'm sorry, in this case, it would be one side of the inequality sign. Well, before, our general rule of thumb is to move the smaller one. That's really a 1p, so that's smaller than a 4p, so I'm going to subtract that. So what do I get? I get 7 is less than or equal to 10 plus 3p. Now we just continue solving like we have before using SADMAP. So subtract 10, so I get negative 3 is less than or equal to 3p. And notice how I didn't flip because I subtracted a 10. I didn't multiply or divide, I just subtracted a 10, so I don't flip the sign. Last step here, divide both sides by 3. So I get negative 1 is less than or equal to p. Okay? But remember what we said yesterday, we don't like to have the variable on the right-hand side. I'm actually going to rewrite this as p is greater than or equal to negative 1. And let's just make sure that makes sense. Again, which way is my mouth opening? Well, my mouth here is opening towards the p, right? Imagine if we did a little Pac-Man here. It's eating the p, okay? So here, it's eating the p again. So when I rewrote it, all I have to do is just make sure that it's still doing the same thing, still facing the p, okay? So again, that's not a flip, it's a rewrite, okay? So let's just make sure that that's a rewrite. P is greater than or equal to negative 1. From there to there, it's a rewrite, okay? So again, negative 1, well, we have to use a closed circle here because we have a greater than or equal to. And again, what are the numbers that are greater than negative 1? Well, those are all the numbers to the right. All the numbers to the right are greater than or equal to. Again, if it helps, use that arrow. This right here looks like an arrow pointing to the right, so I'm going to go shade to the right. Okay, I think that was enough of a recap. I think we should be able to tackle the next set of problems. So I see right away variables on both sides. I'm going to move my smaller one. I'm just subtracting. I'm not multiplying or dividing, so there's no need to change the symbol. So I get 3 is less than 2x plus 5. I'm going to now solve for x, so I'm going to subtract 5. I get negative 2 less than 2x divided by 2. I get, actually, let me go ahead and rewrite it first. This is negative 1 less than x, but remember, we don't like it like that. We want the variable on the left side, so it's really x is greater than -1. Again, look at this moth right here, guys. It's opening to eat the x, so when I rewrite it, it's opening to eat the x, okay? So it's x is greater than -1. Don't need a closed circle, just an open circle. And again, what are the numbers that are greater than -1? Everything to the right. And if it helps, draw your little arrow right here. That symbol is very similar to this symbol, okay? So we're shading to the right, okay? All right, not too bad, right? Well, let's try the next one. Right away, I see that parentheses, and we know that we usually should go ahead and distribute first, okay? So let's go ahead and distribute both of those. So that's -40 plus 10r is greater than 2r. Now we have variables on both sides. Again, we would usually like to move the smaller one, but look, if I move the 2r, then I'm not going to have anything on the right side. But what I'm actually going to do is get rid of the 2r. That way I have the variables on one side and the constant on the other. So what do I get? I get -40 is greater than -8r. Now look at what I'm doing. I'm dividing by a -8. So that means, what do I have to do? If I divide by a negative number, well, first off, -40 divided by -8 is a positive 5. But I divided by a negative, so my symbol has to flip. And then I just get my r here. But even after a flip, I'm going to have to rewrite. Okay, meaning I want the r to come first. So r is greater than 5. Pac-Man's eating my r. Pac-Man's eating my r. Okay, cool. So we have r is greater than 5. Sorry, guys, I'm trying to make sure I'm working a little neater here. So let's see, r is greater than 5. So let's go ahead and draw my 5 there. It's not equal to, so it's just an open circle, and all the values greater than 5 are all to the right. Again, this right here is like an arrow going to the right, so I'm going to draw everything to the right. So shade everything to the right. Okay? All right, let's keep going, guys. I think I'm going to try one more with you guys, and then I'm going to have you try one on your own. I'm actually going to skip number 3 because I want you guys to try that one. I'm going to do number 4 with you guys. So there's no need for distributing anything, okay, because there's no parentheses. However, if we look on either side of the equal sign, or in this case, the inequality sign, we actually have to combine some like terms here. So these two are like terms, and these two are like terms, right? So let's go ahead and combine those. So we get -7, that becomes a -7a, it's greater than or equal to -2, and what is that? -8a. Okay, now I have combined like terms. Now I just get the variable on one side of the equal sign. Well, let's move the smaller one. In this case, it's the -8a. So I'm going to add 8a. I get -7 plus a that's greater than or equal to -2. Final step is to add the 7. Got a little ahead of myself there. So I get a is greater than or equal to 5. Notice I did not have to flip, rewrite, or do anything this time. Okay, I just solved kind of like I would an equation. So again, number goes there right in the center. This time it does have an equal to sign. So I have to shade my circle so it's a closed circle. And again, it's a is greater than 5, so all the numbers that are greater than 5 are to the right. All right. Why don't you guys go ahead and try number 3 and 5 for me? So go ahead and pause the video and try 3 and 5, please. All right, let's go ahead and try 3 and 5. Hopefully you guys have your answers by now, and that way you can compare answers with me, see if you guys got the same answers. So we got 4 times 4n, that's 16n. Minus 16 is greater than or equal to 32 plus 8n. We have variables on both sides, so let's move the smaller one. So I get what? 8n minus 16 is greater than or equal to 32. Continue solving by adding the 16. So we get, and I'm going to move over here, 8n is greater than or equal to, this was 48. And I'm dividing by a positive 8, so no need to flip the sign. So I get n is greater than negative 6. And actually, there's no need to even rewrite either. So I get 6 here. Excuse me. So I have a 6 there. It is equal to, so I have to go ahead and shade it in because I have a closed circle. And then that, once again, is everything to the right. X is greater than or equal to greater than or equal to positive 6. Okay, cool. So let's go ahead and see how you did for number 5. Whoa, too much. Okay, let's go ahead and distribute. 2/3 times 3x is actually a 2x. 2/3 times 18, so 2 times 18 is 36. 36 divided by 3 is a positive 12. Greater than or equal to 5x minus 9. Now, let's move our smaller variable. So I get 12 is greater than or equal to 3x minus 9. Add the 9. I get 21 is greater than or equal to 3x divided by 3. So I get 7 is greater than or equal to x. But I don't like that. I want my variable on the left side. So if I rewrite, I can go ahead and write it like this. So it's kind of like you're changing the symbol, kind of like you're flipping it, but technically you're not really flipping it, you're just rewriting it, because right here, again, if you draw your little Pac-Man, it's going like it's going to eat the 7. So if you draw your Pac-Man right here, it still looks like it's going to go eat the 7. And I know my Pac-Mans look horrible, but don't make fun of me. Okay? All right, so we have x is less than or equal to 7. I'm going to put down my 7. It is going to have to be a closed circle because I do have an equal to sign. And look at that. My little symbol here looks like an arrow pointing to the left. Kind of like this is pointing to the left. So I'm definitely going to shade to the left. And again, guys, remember, if that doesn't quite convince you just yet, I would say go ahead and substitute in a value there. So what are some values that are less than 7? Well, what about 0? 0 is somewhere over here, right? So is it true that 0 is less than or equal to 7? Yes, it is. That's true. So we know we shaded to the right side. Okay. Now number 6 just looks like a lot of work. But besides that, honestly, it's the exact same thing, guys. So don't let little things like that intimidate you. We just have to go ahead and do more steps, but we know those steps, so it won't be hard. So we have 4 minus 4x after distributing, and we still have that 3x there. After distributing that negative 2, we get negative 2x minus 2. Okay, so distributing was the first step. After that, you have to check to see if either side of the inequality has like terms. Well, on the right side, you can't combine the negative 2x and the negative 2, but on the left side, you could definitely combine the negative 4x with the 3x. So what do we get? We get a 4 minus 1x, which is just 4 minus x, minus 2x, and negative 2 on the other side. Now, move your smaller variable, because you have 2 of them. So I'm going to move the negative 2x. Again, remember, if you move the smaller variable, guys, that's kind of preventing you from needing to get a negative coefficient in front of the variable term, which actually in inequalities is really important because that means we don't have to flip as much times. Okay, so let's go ahead and cancel those out. So what do I get? I get 4 plus x is greater than negative 2. Subtract the 4, and we get x is greater than negative 6. Okay, so let's go ahead and draw our negative 6, and it's x is greater than, so no need for a closed circle, just an open circle, and greater than, yet again, is pointing to the right, so shade to the right. All right. Well, it looks like we just have quite a few more problems that we need to go ahead and try out, but again, they're all just inequalities, and we do similar procedures to equations. The only big thing that we have to remember is that with inequalities, if you multiply or divide by a negative number, you have to flip the sign. Okay? I guess the only other thing is to remember that if you need to rewrite to get the variable on the left side, then go ahead and do that. Okay, guys? So let's continue with these problems. Distribute the negative 4, and negative 4 minus 20m is greater than or equal to negative 96. All right. Well, there's no need for combining like terms on either side of the inequality, and there's no need to move the variable because it's already on the left side. So let's just go ahead and solve using StatMap. So what do we have? We have negative 20m is greater than or equal to 100 divided by negative 20. Well, what did we just do? And always remember that, guys. What did we just do? I divided by a negative, meaning I have to flip my inequality sign. So now it's a less than or equal to, and this becomes a less than or equal to negative 5. So we have a negative 5 here. Well, do we need to actually go ahead and do an open or closed circle? Well, in this case, we have to do a closed circle. So closed circle, and this inequality symbol is like pointing to the left, just like this is. So I'm going to shade to the left. Remember, guys, that trick or that whatever you want to call it, trick, shortcut, whatever, only works if the variable on the left side of the inequality. So again, that whole trick with looking at the symbol and looking at like an arrow, looking at it like an arrow, see how that looks like an arrow pointing to the left? That's why I shaded to the left. Only works if this variable term is on the left side of the inequality. It will not work if it's on the right side, okay, guys? So let's go ahead and take a look at number 8, and then I want you guys to try out number 9 and 10 on your own. So first things first, I already have, let's see, no distribution needed, no combining like terms on either side of the inequality needed. So go ahead, go straight to StatMap. So get rid of addition and subtraction first. So I have k divided by 2 is greater than 2. How do we get rid of dividing by 2? We have to do the inverse operation, which is multiply by 2. So I get k is greater than 4 is my answer. That's my solution set. I have to do a 4 here. This takes an open circle because we only have a greater than, not a greater than or equal to. And again, we have my variable on the left side, so it's okay to do my little arrow thing, my little arrow trick that's pointing to the right. So I'm going to have to shade to the right. All right. So I want you guys to try out number 9 and 10, and we will come back to verify that you guys are understanding this type of problem well. All right, go ahead and pause the video now and try those out. All right, guys, let's go ahead and see how well you guys did on those few problems. So let's see what we got. First things first, solve that distribution that I need to do. So I have W minus 11 is greater than 2 minus W plus 15. Okay. All right. Now the next thing. Let's see. Can I combine like terms on either side of the inequality? Yes, I can. I can combine the 2 and the 15. So what do I get? I get W plus 11 is greater than 17 minus 3W. Okay. Now I have variables on both sides. Get rid of the smaller one. The smaller one is this negative 3W. So I'm going to add 3W. I get 4W minus 11 is greater than 17. Remember, keep your greater than symbol because we still haven't needed. There's no need to change it just yet, and there might not need to be a need to change it. So 4W is greater than 28. Divided by 4, we're divided by a positive, so no need to flip it. So we just get W is greater than 7. So let's go ahead and draw our solution set. So what do we get? We get a 7 here and an open circle because we don't have an equal to, and it's going to the right, so we shade to the right. Okay, so we are shading to the right. So hopefully you guys got number 9 correct. Now let's see if you guys actually got number 10 correct as well. So let's see what we get. Distribute right away for sure. You see 2 sets of parentheses, so go ahead and distribute. We get negative 5 plus 6m minus 30 is less than or equal to negative 8m plus 24 minus 3. Can I combine anything on either side of the inequality? Yes, I can. I can combine those two, and I can combine those two. So what do I get? Negative 35 plus 6m is less than or equal to negative 8m plus 21. What's the next step? Well, the next step is to get the variables on one side of the equal sign. Smaller one here is negative 8m, so I'm going to add an 8m. So I get negative 35 plus 14m is less than or equal to 21. Now it's straight SADMAP, so let's go ahead and add 35, add 35. I get, whoops, let me grab the right pen here. I get 14m is less than, well, let's see, what is that? That's 56, if I'm not mistaken. Okay, 56. Now we just finally divide both sides by that 14. And again, no need to flip the sign because we are getting, or we are dividing by a positive number. So we get m is less than 4. Okay, and actually, oh, I forgot to rewrite my equal to sign there. So m is less than or equal to 4. So actually, I should have a 4 here and a closed circle because I actually have a less than or equal to, so I have to definitely have my closed circle there, and then it's less than, so less than is left. That's another way of remembering less than left, so I shade to the left. All right, cool. So hopefully you guys had those two correct. Now I almost missed that equal to sign there, guys, so if for some reason I did miss that on any of the top problems, make sure you guys correct it for me. So make sure you guys have it correct on your paper. If I for some reason messed it up and you guys noticed it, please by all means change it, guys. I am human, so I do make errors. However, for the most part, I think I have my bases covered. So you should be double checking your work on whatever I have written down. But again, always double check it. Make sure that you are correct or I am correct. Doesn't matter as long as we can identify what we did wrong and we can go ahead and fix it from there. Okay. So number 11 and 12. Now I can tell you right away that this is going to be a little bit of a special case, but let's identify why. Why is that true? Okay. Let's go ahead and just like before, we see a parentheses, so we get 3w minus 11 is less than 2 plus 3w minus 15. Can I combine any like terms? Yes, I can. I can combine those two. So what do I get? I get 3w minus 11 is less than, I'm actually going to put the 3w first, and then 2 minus 15 is a negative 13. Okay, well, if I move the smaller variable, which in this case they're both exactly the same, you'll notice that actually both of those go away. All you're really left with is negative 11 is less than negative 13. When is that true? When is negative 11 less than negative 13? Okay, that's actually never true, guys. Okay, and notice there isn't even a variable here. Okay, at this point we're just trying to identify, is this true or is it ever true? Okay, and actually this is never true. Okay, so it's not true. So just like before with equations, what do you guys think my solutions are here? Okay, in this case I have no real solution. I have no solutions because that is never true. Negative 11 is never less than negative 13. Okay, so how does that translate onto my graph or onto my number line? Well, exactly like that, exactly how it is now. There is no solution, so you can't mark anything on there. So you actually have to go ahead and leave that blank. Okay, so I hope that made a little bit of sense. Let's go ahead and take a look at another special case here with number 12, and hopefully that will clear things up a bit. So, number 12. Notice here and here, I can combine like terms. So I get negative 5a minus 3 is greater than or equal to negative 5a minus 3. And I don't even have to go ahead and add the negative 5a, add the 5a to both sides, because look, aren't both sides of the inequality exactly the same? Okay, well, let's just go ahead and do it. Let's go ahead and add the 5a. All right, I get negative 3 is greater than or equal to negative 3. Is that true? Well, negative 3 is not greater than negative 3, but this is saying negative 3 is greater than or equal to negative 3. So this part of the statement, which let me go ahead and rewrite here, is not true ever, but we're saying this is an or statement because it's greater than or equal to. What about that though? That's included in this right here. Negative 3 is equal to negative 3. Is that true? Yes, it's true. When is it true? Well, it's always true. Okay? That's like saying, are you all the time? Well, yes, you can't be someone else. You're always you. Okay? So that means that this is always true. And we know from before that always true means all real solutions. Another way of saying it is infinitely many solutions. Now, honestly, with inequalities, I prefer this answer. Even though they can mean the same thing, they don't necessarily mean the same thing. With equation, it was okay to write either or, but honestly, and this is just my matter of opinion, I would prefer all real solutions for this because when you look at your number line, you would actually have to shade everything because that statement negative 3 is equal to negative 3 is always true. So you would have to shade everything. And I don't know why that just erased on me, so I'm going to go ahead and actually use a highlighter. You have to shade everything, okay? Now, the reason why I'm saying that I would prefer all real solutions over you saying infinitely many solutions is because infinitely many solutions, technically, this up here for problem number 10, that entire solution set that you guys see right here, those are infinitely, and I totally butchered that word, infinitely many. Technically, that's infinitely many solutions, okay? So any solution set besides just having an answer of just one particular answer will be infinitely many solutions, but I won't even start to get close to explaining why any of that's true. Now, just know that if you have any situation like this where you have something that is always true, try to write it as all real solutions rather than infinitely many solutions. Okay, let's keep going because we still have quite a bit of this to go. I'm going to go ahead and do number 13 and 14 so we can finish off, and then you guys can continue on with me for 15 through 18. They are a little bit different, so we'll go ahead and talk about both of those situations. So let's distribute that. What do we get? We get 2b minus 15 is greater than 8b minus 6b minus 30. Can I combine anything? Yes, I can. I can combine those two. So what do I get? I get 2b minus 15 is greater than 2b minus 30. Let's actually subtract the 2b. What do I get? I get negative 15 is greater than negative 30. Well, think about that. Is negative 15 greater than negative 30? And in this case, yes. Always true. Negative 15 is always greater than negative 30. And hence, how many times is it true? It's always true. So how much do I shade? I shade all of it. I shade all of it. Okay? So what would you say here for your solutions? You would say all real solutions. Or actually another way you could say this is all real numbers. Either of those two answers would be correct. Like I said, I'd prefer you not say infinitely many solutions, but again, just know that I prefer all real solutions or all real numbers. Okay? This last one right here for number 14 that we're going to deal with for solving, let's go ahead and finish it up. Get negative 10m plus 20 is less than or equal to negative 10m minus 20. Okay, so let's go ahead and add 10m to both sides. I get 20 is less than or equal to negative 20. Is that true? Well, again, this statement right here is like asking both of these questions. Is 20 less than negative 20? Or is 20 equal to negative 20? This is just basically a merger of these two things right here, guys. Okay? Actually, I should draw it the other way. Like that. Okay? So this statement right here means both of those. Is 20 less than negative 20? Or is 20 equal to negative 20? Well, 20 is definitely not equal to negative 20, and 20 is definitely not less than negative 20. And because none of those statements are true, you would say no real solutions. So how much do you draw or shade or whatever? You shade nothing. You just leave a blank number line. Okay, so I'm hoping that was enough practice for you guys to see how inequalities are similar to equations in solving. We just have a few different things that we have to consider when we are doing inequalities. Okay, so let's go ahead and look at this last bit of information we have here, and then we will be done for the day. Okay, let's go ahead and take a look at number 10. So, all right. Sorry, not number 10, number 15. It says, write the inequality represented in the graphs below. So, just like we did yesterday, we can go ahead and write what those are. Okay. I'm going to do 2 of them, and then you're going to do 2 on your own. So this is just like we did yesterday. Again, use x as your variable. I like to start with just writing the x on the left side because I always like the variables on the left, and my number on the right. Now it's just a matter of identifying what symbol I use. Well, it's an open, right? It's open circle, so which ones can we use? Less than or greater than. So which one am I going to use here? I'm going to use, well, which way is this arrow pointing, or which way is this arrow being shaded towards? Towards the right. So what symbol did I just kind of highlight there? That's a greater than symbol, so it's greater than. Again, if you can try out a few points. -7, -6, -5. Well, is -5 greater than -8? Yes, it is. So this right here is definitely true. So we know we use the right symbol. Okay. Next one. I have an X. Whoops. I'm using a highlighter still. Let me switch to a pen. I have an X and I have a 6. Now it's a matter of understanding which symbol to use. Well, this is a closed. So what are my 2 choices? Less than or equal to, or greater than or equal to. Well, this is being shaded to the left, which means we have to use a less than sign, and don't forget your equal to because it's a closed circle. All right, guys, so 17 and 18 are for you guys to try out, so go ahead and pause the video and try these 2 out. Okay, guys, let's go ahead and try these 2 problems out. Start out, x and -3. This is an open circle, so my choices are less than or greater than. I can see right here, it's going to the left, or it's being shaded to the left, and that I just shaded there looks just like a less than sign because a less than sign would work there. Okay, again, try out a number if it doesn't convince you. -6. Is -6 less than -3? Yes, it is. Boom, it works. Okay, last one, number 18. X and 0. This is a closed. So less than or equal to or greater than or equal to are the only choices. Now it's being shaded to the right, and this arrow over here looks just like a greater than symbol, so if x is greater than or equal to 0. Alright guys, I think that's it for our video for 4.2. So go ahead and rewatch any section of this that you probably need some more help on, or you think you need some more help on. But if you feel comfortable, make sure you go ahead and move on to 4.3. But even before that, I would highly recommend you guys try out your homework and double check and make sure that everything makes sense. Remember, to recap this entire section is understand that solving equations and solving inequalities are similar yet different. They are similar in terms of following the same steps. However, they're different in the fact that we have extra rules for inequality, those being that you have to flip. Okay, if you multiply by a negative number, or if you divide by a negative number. And you guys might also have to rewrite. Okay, you might have to rewrite it if the variable is on the right hand side of the inequality. Make sure you rewrite it so it's on the left side, so you can go ahead and draw your number line. Okay, and I think that would be basically the summary of this section. So go ahead and watch any part of this video if you want to make sure you refine your skills in that particular subset. And I think you guys will be ready for the next section. So I will talk to you guys later. All right, have a good one, guys.